All right, so good afternoon, everyone, and welcome to our first episode for our Iwas to Natin webinar series. So we have organized this series on sustainable solid waste management amidst COVID-19. So as we know, we are still experiencing this COVID-19 pandemic, and it has already made a serious global impact on the waste sector. So as we go on, as we transition to the so-called new normal, we also need to adapt, no, to new challenges and challenges, especially sa disposal, handling, and management ng solid waste in our local communities. So that is why we have organized this webinar series. So we titled this Iwas to Natin, and we will tackle various topics on sustainable solid waste management. So for this episode, we will be presenting the different technologies on the management of biodegradable wastes. Okay, so all right, so before we move on to the formal or official start of our program, let me remind our participants to, if you can, please change your name after entering this meeting to your name and organization so that we could acknowledge everyone and we could list our participants here. And also, please keep your mic and your video disabled at all times. Okay, so that the moderator, which is me, and the speaker's video will show on screen. So again, please keep your mic and your video disabled. And also, after the sessions or the presentations of our invited guests, we will have a moderated Q&A. So send your questions later to our chat here in Zoom. So, or if you are a live Facebook viewer, you can also comment your question. Just input your name and institution before your question. All right, so we could also acknowledge you. And then we will record and share this webinar online, so that other participants who cannot join here in Zoom can also watch this session. And lastly, just enjoy, and we hope that you will learn from this webinar and you could apply this also in your work. So we are very thankful for the interest that you have shown, and we have received a lot of registrants for this session. Okay, so next. All right, so our first episode will be on the management of biodegradable wastes. So we will talk about the locally developed waste utilization technologies of DOST ITDI. So we have invited them here. And next, all right, so just so we could level your expectations for this session, we will be introducing our project. So what is Project IWASTO, and why are we doing this? No, and of course, we will also introduce and discuss the different technological options of Project IWASTO in terms of managing biodegradable wastes. And lastly, we would like to gather the support of our stakeholders in the implementation of Project IWASTO. So we have invited participants from our LGU, CENROS, and of course, we have opened this to the public. So next. So this will guide our program for today. We will first give a short overview of what Project IWASTO is, and that will be presented by our project leader, Dr. Maria Antonia Tanchuling. And then after this overview of our project, it will be followed by the presentations from our invited speakers. So that will be Dr. Mayra Tansenko and Engineer David Herrera from DOST ITDI. So after that, we will have a moderated Q&A just so they could address your questions if you have any questions regarding their presentations. Okay, and after that, we will close the event. All right. So let's move on to our first part of the program. So this will be just a quick overview of what we are doing in Project IWASTO, and it will be presented by our project leader. That's Ma'am Tonette, Dr. Maria Antonia Entanchuli. And she is also a professor and the director of Institute of Civil Engineering at the University of the Philippines, Diliman. So good afternoon, Ma'am Tonette. You can take it from here po.
Yes, good afternoon. Thank you. Thank you, Roda. By the way, hindi yata nagpakilala si Roda. That was Roda Ramos, one of the staff of our project IWASTO. So magandang hapon po sa inyong lahat. Maraming salamat sa inyong interest. No, we are really happy that we got a lot of registrants. So I hope we're able to accommodate you through Zoom and that, or you can access our FB Facebook page. So magandang hapon po. Ang IWASTO po ay ibig sabihin Integrated Waste Analysis Survey and Technological Options or Project IWASTO. Ito ay part ng a bigger program called I Am for Manila Bay. No? Next slide please. Sige, briefly muna yung I Am for Manila Bay. As we know, malaki ang interest talagang we really have to may program no na clean up ng Manila Bay. So part of that we made a proposal to DOST and DENR to contribute no in the rehabilitation of Manila Bay. So may iba kaming projects na kasama because we know iba-iba ang pollutant sa mga ilog patungo sa Manila Bay. So merong dredged materials, so may isa ring project on dredged materials, tapos hydrodynamic modeling para tingnan kung paano gumagalaw ang mga pollutant sa bay, and then meron ding mappable no to map all the sources of pollution and to show it visually no. So lahat naman yan magkakaugnay. So sa part namin, IWASTO is one of the projects of I Am for Manila Bay. So sa IWASTO, alam natin na isa sa sources ng pollution sa Manila Bay ay basura. So kitang-kita yan, no? Lalo na sa urban areas. So ito yung gusto nating tugunan, no? To be able to respond to this environmental challenge. So next slide, please. So every time it rains, no, we see this images, basura na parang binabalik sa Manila Bay. So galing din ito sa mga ilog, no? Lahat draining towards Manila Bay. Aside from NCR, meron din Bataan, Pampanga, Cavite, no? Lahat yan nagko-contribute sa Manila Bay. So in terms of amount of basura na napoproduce ng mga city within Metro Manila, ayan nakikita sa ating screen, no? Syempre ang Quezon City dahil sila din naman ang pinakamalaking city, no? Pinakamaraming population. So marami rin ang na-generate. Yan ay na-generate na waste, hindi naman yung napupunta sa environment, no? Just to illustrate. Okay, next slide please. So gusto natin itong i-address and we want to prioritize yung options na yung mga nasa taas, no? First, ang una nating gustong unahin na option ay reduction. Ang basis nito ay gusto rin talaga natin ay less use of resources. So we reduce in the first place consumption, no? Kontian natin ang ang paggamit ng mga bagay, lalo na ng mga hindi kailangan. And then kung kailangan talaga nating gamitin, mag-reuse. And then next ay pwede din namang mag-recover, no? Yung may mga let's say nutrients, no, sa mga nabubulok na bagay sa biodegradable component, pwede nating ma-recover ang nutrients at pwede pang magamit, no, instead na tinatapon na lang. So pwede ring mag-recycle, and then yung sa disposal part na is thermal treatment with energy recovery, for example, incineration. And then final, kung wala na talagang ibang mapupuntahan or yung para sa mga residual waste, yung wala nang mapapaggamitan, yun lang sana ang napupunta sa landfill. So ang training natin ngayon ay tungkol sa paano natin mare-recover, no, yung nutrients sa biodegradable component, na yun yung ipapaliwanag ng ating mga trainers maya-maya. Okay, next slide please. So gusto nating no, ang isang estado, no, na yung waste management natin ay sustainable. So we want to achieve sustainable waste management. So paano natin to magagawa? Kailangan nating mapag-aralan, kailangan nating maggamit ulit yung mga basura na meron tayo through recovery or recycling. Pero para makapili tayo ng kung ano ang angkop, kung what is appropriate na waste utilization technology, kailangan nating aralin ano ba yung characteristics ng basura natin, ano ang nandyan, ano ang composition, gaano ba siya kabasa, tapos ano yung practices, paano siya kinokolekta, no, saan tinatapon ang ating mga basura, plus yung mga consideration for the environment, the social and economic and technical aspects. So lahat ng yan, sama-sama kailangan nating aralin para makapili ng angkop na waste utilization technology. So para din ito mangyari, no, para ito maging effective and efficient, kailangan nating aralin, kailangan itong suportahan, no, ng policies. So we also have policy support and involvement ng community, no, which is very important. Yon, next slide, please. So yung objectives ito, siguro hindi ko babasahin talaga literally lahat, pero ang target area namin, because this is for the rehabilitation of Manila Bay, yung part ng watershed dito sa Manila Bay watershed, so specifically mga Pasig, Navotas, Malabon, Marilao, Malinta, Obando, no? Pero of course, when we do mga training na ganito, we invite everyone kasi applicable naman ito sa lahat, and sana mag-benefit din, no? Marami namang lugar na pwede pa itong magamit. And then so kailangan nating malaman yung to evaluate waste management practices. Sorry, yung previous slide please, hindi pa ako tapos. And then ma-utilize ang to recommend appropriate waste utilization technologies, and then mapag-aralan ano-ano bang facilities ang available, like may MRF ba, nasaan sila, anong mga material ang kinukuha nila, kasi malaking bagay din ito para mag-guide ang mga tao kung saan magdadala ng kanilang mga basura na hindi naman kailangang itapon, no? Baka may pwede pang paggamitan. Next slide, please. Yan. Tapos gusto nating in the future, ano bang mangyayari? Halimbawa, dumami ang ganitong basura, saan siya mapupunta? Ayan na, yung one of our main objectives is to be able to put up on a pilot scale at least 2 waste utilization technologies to process biodegradable and plastic waste. So plastic waste, dahil alam natin ito ay isang malaking problema dahil hindi siya nagde-degrade in nature. And so at marami tayong nakikita sa mga ilog, eventually sa dagat, and ang Pilipinas daw ay third largest contributor ng plastic sa oceans. No? So ito ay isang aspect na dapat nating tugunan. Sorry na wala yung PowerPoint. So hindi ko na makita. Sige, from memory. Sorry, nawala. Next slide, please. Next slide. Next slide. Ayun. So we will set up two waste utilization technologies. Yung isa for plastics, yung isa for biodegradable component na alam natin na napakalaking bahagi sa ating basura, although nabubulok siya, pero malaking bahagi ng na tinatapon na basura ay nabubulok, and marami pa itong gamit sana, no, na iniiwasan natin na mapuno ang ating mga landfills. So gusto natin siyang magamit. Yon. So ang methodology namin, we will do waste analysis and characterization studies, inventory ng mga waste management facilities, tas tingnan yung mga polisiya, simulation ng mga future waste generation rates. Next slide, please. Yon, yung setting up ng appropriate waste utilization technology. So again, ito po yung naghahanap pa lang kami ng partner ngayon dahil sa pandemic, no, hindi kami masyadong makalabas. Pero we'd really like to be contacting and networking with LGUs who are willing to have these technologies, no, sa community, even on a very small scale, not even on a barangay scale, no, even mas maliit pa. So as we have said, we would like to use the technologies na na-develop na ng ITDI, ng DOST, at gusto nating i-set up sa community. So kaya we're doing this training, no? Aside from sharing the technology, yung kaalaman tungkol dito, isa ring purpose na mention ni Roda kanina is to find partners, no, interested partners. So right now hindi pa kami naka-establish, sana somewhere in Manila. Okay, yung discharging to Manila Bay, part of Manila Bay watershed. We'd also like to systematize our waste data that is being collected and have it available to the public. I think malaking bagay ito, no, yung para alam ng general public kung ano ang nangyayari, yung mga data tungkol sa basura. And then finally, policy recommendations para magamit yung mga technology, and of course contributing to sustainable solid waste management. Yeah. Next slide, please. Yan na. So yung the activities that we have to do, we have to coordinate with LGUs, the government agencies, the NGOs, no, those working directly with the communities, and then collaboration with the other projects. Tas yung pagtingin, no, ng malaliman sa mga waste utilization technologies, ano ang kailangan dito, anong mga emissions, and then scenario analysis, and then next slide, please. Inventory ng existing facilities, MRFs, dump sites, kahit open dump sites. No? Kasi malaking bagay yon yung nare-report natin ng open dump sites para mapasara. And then mapping that information, and then the technology itself, no, setting it up and monitoring, and yan yung the database and app development, and making it available to the public. Next slide. So ito po ang aming staff. It's a multidisciplinary complement, no. So ako po again si Tonette Tanchuling na project leader, and then the senior research specialist is Jella Aquino, and then we have a team, mga communications team, and then composed of, we have faculty members from UP, and also mga full-time staff, no? We have communications, and for community development, community organizing, and then the technical component, no? People for working on the biodegradable component, and then also the plastics component, and then later on yung sa IT part, yung GIS and app development. We will include staff from those areas. I think that's the next slide. Next slide, please. Yan. Marami pong salamat. Again, thank you very much for your interest. Sana, hope you will find this training helpful and something that you can use later, no? Para po sa mga interested na potential na partners, we'd really like to work with you. So, welcome po sa ating training, and good afternoon. Thank you. Back to you, Rhoda.
All right. Thank you, Ma'am Tonette. Thank you for that very comprehensive overview of our project. So again, this project will be ongoing for 2 years. So that will be until 2022. So nakalimutan ko palang magpakilala. So ako pa pala si Rhoda. So I will be your moderator for today. And I am the communications officer po of Project IWASTO. So right now, let's move on to the next part of our program. So that will be the presentations of different technologies for managing biodegradable wastes. So for our first speaker, let me first introduce Dr. Myra Tansenko. So our first presenter for this webinar is Dr. Myra Tansenko, and she is a supervising science research specialist at the Environment and Biotechnology Division of the Department of Science and Technology, Industrial Technology Development Institute, or that's the DOST ITDI. Okay, so she obtained her doctorate degree in engineering under the biotechnology program from Osaka University in 2004. She is also involved in various projects, researches, and publications related to solid waste management, biological treatment of wastewater, utilization and optimization of biogas system, and waste analysis and characterization studies. And in 2019, Dr. Tansenko received the DOST Utility Model Registration Award from the National Academy of Science and Technology for their utility model, the anaerobic sequencing batch reactor. And Dr. Tansenko is also an experienced resource speaker and trainer on waste analysis and characterization studies and the operation and maintenance of the bioreactor composting technology and small-scale composter. Okay, so Ma'am Myra, are you there po?
Hi, good afternoon.
Okay, ma'am, you can take it from here po.
Okay,
Have
so
your presentation.
can I have my slide, please? Ayan. Sige po tayo. Okay, so this afternoon I will discuss the composting technologies developed here in ITDI-DOST. Next slide, please. So based from RA 9003, or the Republic Act, Ecological Solid Waste Management Act, we need to segregate our solid waste at source. So we need to properly sort our waste at home, in our offices, and in industrial and commercial establishments. Next slide, please. Next slide, please. So there are four major waste categories. Can I have the previous slide, please? So there are four major waste categories. One is biodegradable, and then which should be processed into compost. Recyclable waste, which are normally collected in junk shops and recycling facilities, and then special waste, which should be collected by accredited treatment plant, and residual waste, which should go to landfill. Next slide, please. Next slide, please. So if we are going to look at the waste characterization data, previous slide, please. Previous slide, please. If we are going to look at the waste characterization data, we can see that the Philippine solid waste is largely composed of biodegradable waste. So this has great potential for composting. Next slide, please. Next, yeah. So here in ITDI, we develop various composting technologies to manage this biodegradable waste. So one is the bioreactor composting technology, which can be used by local government units and establishments generating large volume of waste. And then we also have the dual drum composter, which can be used by barangays, schools, universities, canteens, small farms, and institutions generating small amount of waste. And the other one, we have the household tumbling composter, which was basically designed for home composting. So allow me to give you the details of these composting technologies using our technology videos. So let's have the videos, please. Can we have the videos, please? Okay na ba yung videos natin?
Institute, Department of Science and Technology. Greetings from the Industrial Technology Development Institute, Department of Science and Technology. This presentation will provide information on the ITDI-DOST Bioreactor composting technology as an option for LGU to use in converting the organic wastes into compost. The bioreactor composting technology was developed in 1996, with the aim to provide an alternative technology for management of municipal solid waste, specifically for the organic fraction of solid waste. The feeding capacities of the bioreactor are 500 kg per day or 1000 kg per day. This figure shows the schematic diagram of a stirred-tank bioreactor. Inside the bioreactor are paddles for mixing the materials. Rotation of the paddle is quite slow, that is, 4 revolutions per hour and driven by 1/4 horsepower motor. Organic waste or feedstock is loaded on the top opening port. Through the paddle, materials slowly move into the opposite end where raw compost is discharged. The harvested raw composts are then transferred to the curing area for further degradation and maturation. Here is the composting process using the bioreactor technology. First is material or feedstock preparation, where shredding of organic waste, weighing, and mixing of materials are done. Next is the in-vessel composting using the bioreactor. The composting operation using the bioreactor is continuous, this means daily feeding of organic waste and daily unloading of raw compost. Raw compost harvest is about 50% of the total load. This raw compost is then transferred to the curing area for further degradation and maturation for a minimum of 30 days. Curing piles should be regularly turned and temperature is also monitored. Finally, mature composts are then sieved and packed. Here's the recommended proportion of organic materials for composting. 1 part dry waste and 2 parts wet waste. Dry wastes or the browns serve as carbon source needed by decomposers or the microorganisms responsible for decomposition of organics wastes. while wet wastes or the greens serve as nitrogen source for decomposers. These materials are both needed for optimum composting activity. So, for a 500 kg per day bioreactor capacity, you need a daily loading of about 170 kg of dry waste and about 330 kg of wet organic wastes. For a 1 ton per day capacity bioreactor, you will need a daily input of about 330 kg of dry wastes and about 670 kg of wet waste. You can try this proportion initially, but you can also try 1:1, or 1 part dry waste, and 1 part wet waste, depending on the type of waste materials you have. Here are examples of dry materials or browns. Dried yard waste such as fallen leaves, dry plant cuttings, or dry grass clippings. Sawdust, cocoa peat or core dust, and agricultural wastes such as rice straw, sugarcane bagasse, corn cobs, etc. Wet wastes or greens include kitchen waste such as vegetable scrap, fruit peelings, and leftover food. Market waste such as vegetable scraps. And food processing wastes. You can also use fresh garden wastes, as well as fresh agricultural or farm waste as wet wastes. If available, nitrogen-rich sources can be added in the wet materials. Nitrogen-rich wastes include livestock waste such as manure from poultry, piggery, horse, and dairy farms. This should be added in moderation in the composting mixture. About 10% of the total mixture is recommended if available. Also high in nitrogen level are fish wastes, and green materials such as fresh grass clippings, legumes cuttings, weeds, etc. Composting materials, that is, wet and dry wastes, should be shredded prior to loading into the composting unit. Small particle size of waste materials will allow faster decomposition during composting. Once all the raw materials for composting are prepared, weigh and mix the shredded wet and dry wastes. The moisture content of the initial mixture should be 50 to 60%. This is considered to achieve the optimum moisture content for compost decomposers. Moisture content of the initial mixture can be determined through a simple method called squeeze test. First, get a handful of the mixture, then squeeze. If while squeezing, water drips heavily, it means your mixture is too wet or the moisture content is more than 60%. You can resolve this by adding more dry materials to your mixture. If little amount to almost no water drips when you squeeze, open your hand. If the mixture in your hand forms or clumps into a ball and retains that shape, then the moisture content is just right. You have achieved 50 to 60% moisture content. However, if the mixture crumbles or breaks when you open your hand, it means the mixture is too dry. Add more water or wet materials to the mixture until you achieve the right moisture level. After preparing the right mix, the materials are then loaded into the bioreactor at the top feed port. Loading is staggered to avoid choking the unit. Raw compost is slowly discharged at the opposite end port. In one day, you can harvest about 50% of the total materials loaded. Harvested raw composts are transferred to the curing area. Remaining organic matter are further degraded during the curing phase, therefore, increase in temperature can be observed during curing due to microbial activity. Regular turning of piles, and monitoring of temperature and moisture should be done during the curing stage. After the curing stage, final product is then sieved and packed. Label the compost and store in dry, covered area. Compost is mature and ready for use when the temperature in the pile has dropped to 33 to 35 degrees centigrade, or approximately ambient temperature. The pile has shrunk to about 1/3 of its original volume. Different materials in the substrate or mixture are no longer recognizable. The color is dark brown to black. The material has a humus-like appearance and texture. It should be crumbly or loose. It has an earthy smell or humus odor, and it should have no foul odor. The composting product may be applied in ornamental plants, backyard gardening, landscaping and greening programs. Take note that the quality of compost products depends on the materials used and observance of critical parameters of the composting process. It should undergo appropriate testing and analysis before it can be used for plants intended for consumption. For commercial production of compost, please check the Philippine National Standards for Organic Soil Amendments. This PNS on soil amendments shows that compost for commercial production should be analyzed for basic property parameters, pathogens, and heavy metals, and the product should meet the allowable levels. The PNS for organic soil amendments can be downloaded online. Here are the needed materials during composting operation that you can consider in budget planning. Aside from the composting machine, you will also need a shredder. Common garden tools and supplies. Very important, of course, is the PPE or personal protective equipment. You will also need documentation supplies and personal hygiene supplies. A mechanized shredder is needed to cut the waste materials into smaller pieces to help hasten the composting process. A multi-purpose shredder applicable for wet and dry organic wastes is recommended. A mechanical or digital weighing scale can be used for weighing the waste materials to be processed for composting. A dial thermometer is used in composting to monitor the temperature of the mixture or pile. Here are other needed materials and supplies. Shovel, rake or fork will be used for mixing of initial composting materials, and for turning of compost pile during the curing stage. A compost sieve for sifting out big, undecomposed particles from the final product before they are packed and stored. Pails or drum containers for waste collection and storage. Water sprinklers for applying water into the mixture or pile to maintain the appropriate moisture content. Sacks for storing the final product, and labeling supplies such as tape, scissors, and marking pen. Documentation supplies such as record book and pen, for recording all the details of composting activities. Personal protective equipment or PPEs needed during composting operation include gloves, masks, goggles and boots to minimize exposure to potential waste's health and safety hazards. Workers should also wear proper working clothes, that is, long sleeves and long pants. Alternative to long sleeves or working shirt with arm cloth. Cleaning tools are needed for regular cleaning and maintenance of the composting facility and used tools and materials. To keep the composting tools and area clean. This may include broomstick and dustpan, rags, detergent, disinfectant, and scrubbing pad. Finally, personal hygiene supplies such as soap, tissue and alcohol should be available for HE workers. When choosing a location and setting up the composting facility, here are a few important considerations. The composting facility should be located away from residential areas. The distance from human settlements and source of drinking water or wells from the composting area shall not be within 5 meters. The composting facility for bioreactor unit should have at least 120 square meters with enough space for workers to move around during composting operation. The area should be secured and covered to protect the equipment and tools, preferably with concrete floor and not prone to flooding. There must also be electric and water supply in the facility. The bioreactor requires a 220-volt outlet. For manpower, at least 2 to 3 workers can be designated to operate the bioreactor composting technology. Here is a recommended layout for the composting facility. The process flow should be carefully considered from the entry point of the waste materials, up to the storage of the end product, for better workflow and personnel movement within the area. The facility should have the following parts. Material or feedstock preparation area where you do the shredding, weighing, and mixing of organic wastes. In-vessel composting area where the composting unit is loaded with the prepared biodegradable wastes. Curing area where the harvested raw composts are piled for further degradation and maturation. Screening and packing area where the mature compost is sieved and packed, and finally, the product storage and exhibit area. In addition, a washing area should be put in place for water supply and regular cleaning. Here is the composting facility in Marikina City. Shown here are their composting area with 500 kg per day capacity bioreactor, the curing area with cubicles and ordinary piles, and the storage area. And here's the composting facility in Barangay Balancas, Valenzuela City with their 500 kg per day capacity bioreactor. Their curing area has partitions for separating the piles, and they have an exhibit area for showcasing their final product. Here's the list of bioreactor adopters nationwide. As of January 2020, we have a total of 121 adopters, majority of which are local government units. Some adopters are food processing industries and private farms. We have 4 licensed accredited fabricators of bioreactor composting technology. We have Lamaco in Bacoor, Cavite, Marinas Technologies Incorporated in Pila, Laguna, Pimentel Creative Buildings and General Services in Zamboanga del Sur, and Bestmark Agro-Industrial Enterprises in Santa Barbara, Pangasinan. The estimated cost for fabrication of bioreactor unit. The 500 kg per day capacity bioreactor is about $625,000 in Luzon and about $645,000 in Visayas and Mindanao. While the 1 ton per day capacity bioreactor is about $1.2 million in Luzon and $1.22 million in Visayas and Mindanao, please contact our accredited fabricators to get an updated cost.
ITDI-DOST also developed a small-scale composting machine to cater those waste sources generating small volume of biodegradable waste. This is the dual-drum composter. The dual-drum composter can be used by barangays, schools, small village or compound, small farms, and institutions or agencies generating small amount of organic wastes. The unit is a small-scale motorized composter with a feed capacity of 50 kg per drum. The drum rotation is about 1 minute per revolution, which is operated by a 1/4 horsepower motor. Composting operation is batch type for 4 to 5 days. Just like the bioreactor technology, composting using the dual drum technology is initiated with the startup operation for inoculant propagation. The startup phase or inoculant propagation takes around 2 days. The resulting product can then be used as inoculant for the regular composting process. If the adopter has existing compost pile, the startup phase can be skipped, and the adopter can utilize the compost pile as inoculant for regular composting. The regular composting process is almost the same as in the bioreactor, which include material preparation, in-vessel composting using the drum composter, curing, and screening and packing. The main difference is that the operation in the dual drum composter is batch type. The drum is rotated for 6 to 8 hours per day, and the mixture is unloaded after 4 to 5 days. As in the bioreactor technology, wet and dry organic wastes are used as composting materials. Here is the recommended mixture for a 50 kg drum. You will need 10 kg of dry or brown waste, 20 kg of wet or green waste, and 20 kg of the inoculant, which can be obtained after the startup operation, or from an existing compost pile. Dried yard waste may include fallen leaves, dry plant cuttings, or dry grass clippings, sawdust, cocoa peat or core dust, and agricultural wastes, such as rice straw, sugarcane bagasse, corn cobs, etc. Wet wastes or greens may include kitchen waste such as vegetable scrap, fruit peelings, and leftover food. Market waste such as vegetable and fruit scraps. Food processing wastes. Fresh garden wastes such as fresh grass clippings and plant cuttings. And fresh agricultural or farm waste. Nitrogen-rich wastes such as livestock manure and fish wastes can be added in wet waste, but in moderation. All composting materials are shredded prior to loading into the composter. Once the shredded materials are loaded, run the composter for 6 to 8 hours daily for 4 to 5 days. Check the moisture content of the initial mixture after about 1 hour of running using squeeze test method. Checking of moisture content should be done daily and adjust as needed. This shows the composting mixture before and after the composter operation. After 5 days of operation, the materials are partially degraded, and these are transferred to the curing area. So after 4 to 5 days, the compost mixture is then unloaded and raw composts are transferred to the curing area for further degradation and maturation. Curing phase may take 30 to 40 days. Mature compost is then sieved to remove materials that have not fully decomposed. Large or coarse particles can be shredded and mix with the new batch of materials for loading to the composter. Pack and label the compost, then store in dry and covered area. Site requirement for the dual drum composter is also the same as in the bioreactor technology, except that the minimum covered area required is 50 square meters. Also needed are water and electric supplies, and at least 2 workers. Recommended layout for the composting facility is also the same as in the bioreactor technology, considering the different stages of the composting process. The usual composting tools and equipment are also needed during the operation of the dual drum composter. Basically, these consist of personal protective equipment, shredding machine, weighing scale, common composting tools, cleaning tools, packing and labeling supplies, and personal hygiene supplies. Accreditation of fabricators for dual drum composter started in 2019. So far, we have the following 3 accredited fabricators: Lamaco in Bacoor, Cavite; Suki Trading Corporation in Lapu-Lapu City, Cebu, and Bestmark Agro-Industrial Enterprises in Santa Barbara, Pangasinan. Here's the estimated cost of equipment and composting materials. The fabrication cost of the dual drum composter is about $120,000. Then you will also need shredder and composting supplies and materials. A total of around 290 to 320,000 pesos can be allocated for the composting operation. Please contact the accredited fabricators to get the updated price of the dual drum composter. Here's the list of adopters of the dual drum composter. From 2018 to January 2020, we have a total of 38 adopters. Majority of the beneficiaries are barangays. The next composting technology is applicable for home composting. The tumbling composter was designed for daily loading of household-generated kitchen waste. The unit is composed of 2 30-liter drums as composters. The shaft holds the 2 drums and allows tumbling of the drum composter. The drum body is lined with holes for aeration. And, the bottom trays are used for collection of harvested product. Aside from converting the household kitchen waste into compost, this household composter also allows family members to segregate their own waste, which complies with the RA 9003 or the Ecological Solid Waste Management Act, emphasizing waste segregation at source and composting of bio-waste. Since the organic waste are kept in a closed container, pests such as rats, cockroaches, and flies are avoided. Moreover, it also prevents disturbance by our house pets like cats and dogs. Materials for household composting basically consists of household-generated kitchen waste. This may include leftover food, vegetable scraps, and fruit peelings. Dry materials are added as carbon source for decomposers, and to absorb high moisture content of kitchen waste. Dry waste may include dried yard waste, sawdust, or cocoa core dust. It is recommended to always chop the kitchen wastes and dry materials to speed up the decomposition process in the composter. The procedure is simple: fresh kitchen waste is daily loaded in the composter drum. Dry waste is added on top, then, the drum is tumbled 8 to 10 times to mix the drum content. Once the first drum is full, the other drum is then used for loading of daily generated household kitchen waste. The content of one drum is unloaded when both drums are full. To unload, the drum composter is turned upside down, and the materials are collected in the discharge tray. Harvested raw compost appears brownish to dark, and these are kept in sacks for further maturation for at least 2 to 4 weeks. Mature composts are then screened. The fine compost product appears dark brown to black. Mix with garden soil. The product can be applied in backyard gardening. Coarse materials after sieving can be used as dry materials for daily loading of household kitchen waste. This year, we started the accreditation of fabricators of household tumbling composter. So far, we have the BBM machine shop in San Fernando, Pampanga. There are other fabricators with ongoing processing of documents. So, those are the ITDI-DOST composting technologies for management of biodegradable wastes. Please feel free to send us message if you have inquiries in these technologies. Good day everyone.
All right, so that was the presentation of prepared by Dr. Myra Tansenko for the bioreactor, dual drum, and household tumbling composters. So we also have a presentation from our next presenter. So I will first introduce our next presenter. All right, so while we are preparing the next presentation, so I will introduce our second speaker. So for our next presenter, he is Engineer David Herrera, who is currently working as a Senior Science Research Specialist at the Environment and Biotechnology Division of DOST ITDI. So he is in charge there of the design and operation of the biogas digester technology. And he also acts as the chairperson of the EBD Committee on Inventory and Disposal. All right, so Engineer Herrera is a graduate of Bachelor of Science in Management and Industrial Engineering from Mapua Institute of Technology. He provides trainings on solid waste management technologies such as the portable biogas digester and the dual drum composter. Engineer Herrera, along with his team, has a number of approved utility models also for their technologies in ITDI. So the latest of which are the anaerobic sequencing batch reactor issued in 2016 and the Trichoderma harzianum for the pre-treatment of kitchen wastes for biogas production issued in 2019. So without further ado, can we ask Engineer David Herrera to introduce this next presentation. Hello, sir. Good afternoon.
Hello. Dito ba? Hello. Good afternoon.
Yes, sir. Can you introduce this next presentation, sir? Thank you.
I will give a brief description of how the ITDI-DOST portable came about. The ITDI-DOST portable biogas digester was developed in 2006 or 2005 through the initiative of then DOST Secretary Estrella Alabastro to be used for the conversion of household kitchen waste to biogas. The development of the ITDI-DOST portable biogas digesters was spearheaded by Dr. Silverio, Chief of the Environmental Division of ITDI-DOST in that era. Dr. Silverio retired at ITDI in 2010. The ITDI-DOST portable biogas digester uses blue drums because of its durability, since they are made of high-density polyethylene plastics. By the way, I am Engineer David Herrera. Please enjoy our video. God bless and keep safe. Thank you very much. You can start the video, please.
Development Institute, Department. Greetings from the Industrial Technology Development Institute, Department of Science and Technology. The ITDI-DOST has developed a portable biogas digester which can be used not only for animal waste but also for household or food waste. The biogas technology is an old technology in dealing with animal manure. Typically, pig manure has an open pit for the treatment of waste. The waste in the open pit produces methane and carbon dioxide. Methane and carbon dioxide are greenhouse gases that contributes drastically to global warming. The methane in the atmosphere will be converted to acid rain which contribute to the corrosion of roofings near the area. In addition, the waste from the open pit leaches to the ground and contaminates the groundwater. When the open pit is full, the waste goes to nearby rivers causing drastic water pollution. The biogas technology removes all the potential pollution by entrapping the waste and produces biogas in return. Uncontrolled dumping of municipal waste contributes to air, land and water pollution. Waste materials produces toxic gases, methane and carbon dioxide, which contributes to global warming. Wastewater from the waste leaches out to the ground and contributes to groundwater contamination. In addition, leachates run off to nearby bodies of water such as rivers and lakes. Biogas technology is an environment-friendly, low-cost treatment solution to the growing problems generated by the growing animal industries and municipal garbage. Biogas technology produces high-value gas in return to treating the waste. The table shows the typical values of biogas generation from different sources of waste. Most notably is pig manure, which produces 78 liters of gas per kilogram waste. Pre-treated kitchen waste can produce about 20 to 30 liters of gas per kilogram waste. 1 kilogram of LPG is equivalent to 1.45 cubic meter of biogas. The flow diagram of the biomethanation of kitchen or food waste was based on our research and development. Kitchen and food waste goes through size reduction through shredding. This will enable the bacteria to consume the waste efficiently and effectively. After shredding, the waste will be mixed with Trichoderma harzianum and retained for 3 days. Trichoderma is a fungi degrader and degrades the fibrous content of the waste. After mixing with Trichoderma for 3 days, the substrate is then mixed with an inoculum. The inoculum is an active anaerobic bacterial sludge collected from an operational biogas digester. The mixture is loaded to the anaerobic reactor or biogas digester. After some time, the biogas digester will produce biogas and compost. There are certain factors that should be understood and noted in biogas digestion. pH is an important factor since the bacteria inside the biogas digester lives in a neutral pH. If the pH of the digester is pH 5, this means that most of the bacteria are dead. Biogas production increases when the temperature of the digester is from 40 to 55 degrees Celsius. The minimum retention time of the digester is 20 days. Retention time is the needed time for the bacteria to consume the waste and increase their population. The biogas digester should not be loaded with chemicals that is harmful to the bacteria such as soap, chlorine and acids. Mixing of the substrate inside the digester increases biogas production and essential when dealing with food or kitchen waste. Generally, biogas can be used for cooking, lighting, and fuel for water pump, broiler heater, and generator sets. Biogas sludge can be dried and can be mixed with hog feeds, fish feeds and can be used as compost for plants. The 200 liters capacity portable biogas digester comprises of plastic blue drums. 1 drum is used as the digester and 2 drums comprises 1 gas holder. The digester capacity is about 211 liters while the 2 gas holders have a capacity of 290 liters. The 2 gas holders, when filled with biogas at full capacity, can be used in a biogas stove for 1 hour. One set of portable biogas digester comprises of 1 digester and 2 gas holders. Parts of the digester and the gas holder will be discussed in the next slides. The portable biogas digester comprises of an inlet, a stirrer, a gas outlet, an overflow, and a drain. The diagram shows the different parts of the digester inside and outside. The portable biogas gas holder comprises of 2 drums, 200 and 160 liters drums. The 160-liter drum is placed inside the 200-liter drum. The gas holder will be loaded with water at the brim. The picture shows the gas holder guide. The gas holder guide comprises of a gas inlet and outlet, and a metal C-channel. The CC channel has holes at each end to guide the 160-liter drum from moving upwards and downwards when gas is being produced and utilized. In addition, the C channel adds pressure to the biogas when utilized. The picture shows the portable biogas digesters installed at Marilao, Makian and Obando in Bulacan province to backyard piggeries in that area. The picture shows the portable biogas digester installed at a Korean village in Fairview, Quezon City. The digester was used for leftover food or kitchen waste. The portable biogas digester was installed at a material recovery facility on one of the barangays in Las Piñas City. The picture shows the training on the fabrication of the portable biogas digester in Tanay, Rizal last March 2014. The picture shows the 1,000-liter capacity portable biogas digester which uses an IBC tank as digester. The gas holder is the same with the 200-liter capacity portable digester. The minimum R requirement for the IBC portable digester is 10 square meters with roofing. The IBC portable digester comprises of an inlet, a mixer, a gas outlet, and a sludge withdrawal port. Sludge withdrawn from the withdrawal port can be dried and used as compost. The gas holder is the same with the 200-liter portable digester. The picture shows loading of inoculum to an IBC biogas digester installed in Silang, Cavite. An IBC portable biogas digester was installed at a poultry farm in Gapan, Nueva Ecija. The table shows the daily loading rate of the 200-liter and the 1,000-liter capacity portable biogas digester. In addition, the table shows the needed inputs for the startup operation of the two types of portable biogas digester. In the table, 4 kilograms manure or kitchen waste and 4 liters water can be loaded daily to the 200-liter capacity digester, while in the 1,000-liter capacity, 20 kilograms manure or kitchen waste and 20 liters water can be loaded daily. The estimated cost of the ITDI portable biogas digesters are 20,000 pesos for the 200-liter capacity digester while 32,000 pesos for the 1,000-liter capacity digester. The estimated cost includes a technology fee of 11,000 pesos. The possible accredited fabricators with Memorandum of Agreement or MOA are BBM Enterprises from San Fernando, Pampanga, LAMACO from Bacoor, Cavite and Caba Engineering from Bulacan. If you want to avail of the ITDI portable biogas digesters, please contact our director, Dr. Annabelle Briones. Thank you for watching and God bless us all.
Right, so that's it for the presentation of Engineer David Herrera about the portable biogas digester. So if you have questions, you can save it for our Q&A in a while. But before our question and answer or open forum, let me just give some announcements regarding the claiming of your e-certificates. So please answer this very short. It will take only like 2 to 3 minutes of your time. Feedback form so that we can improve our future webinars. So this is the link for the feedback form. That's bit.ly/EP1 feedback. So please note that this link is case sensitive. So when you type this on your browser, please make sure that letter E and F are in uppercase. And to receive your e-certificates, please submit the feedback form by 3 p.m. today. All right, so even our Facebook Live viewers can submit the form and we will close this by 3 p.m. All right, so next. All right, so this is our Q&A portion. So let me ask again Dr. Myra and Engineer David to turn on their camera and microphone so that we can address the questions. So for our Zoom participants, you can submit your questions on our chat box. Just please input first your name and institution so that we can acknowledge you. So habang nag-iintay po siguro tayo ng questions from our chat box, we have questions from Facebook Live. So marami din pong nanonood from our Facebook Live. All right, so let me just... Okay, so here is one question from our Facebook Live. For the household tumbling composter po, how much space does it need to operate this technology? And what is the minimum household waste generation need? Sorry. Okay, I'll repeat this question. It's from Brando Angeles po. So yung question, for the household tumbling composter, how much space does it need to operate this technology? And what's the minimum waste needed to make the household tumbling composter energy efficient and economically feasible?
One.
For the space in household, using the household tumbling composter, around 1 square meter lang naman yun. And anong other question? Space and?
The other question po is, what's the minimum po na household waste na kailangan para maging energy efficient po yung tumbling composter?
The household tumbling composter was designed for daily waste generation of households. So normally, ang average na household waste generation daily ay around 500 grams. 0.5 kilograms, sorry, 500 grams. So normally naman doon nagre-range yun, more or less 500 grams.
Okay, thank you, Doc Myra. And another question from our Zoom participant. She is Sharon Manuel from UP Diliman. So what is the cost of the household tumbling composter? But I think this was already presented.
For the household tumbling composter, just recently, we had the BBM machine shop as a fabricator. And now we is conducting the prototyping. So after that, he can give the actual price. But the estimated amount of the raw materials only is about 4,000. 4 to 5 yan. Pero pagdadaan kasi sa fabricator, syempre meron na yung markup and so on. So you can check later on sa accredited fabricator namin.
All right. Thank you, Doc Myra. Again, here's another question from Jihan Adil of WMSU. Or what are the requirements for accreditation as fabricators?
Okay, for accreditation of fabricators, we have the normal process. They have to contact our Technology Services Division, and then they will provide you with the form and so on. Just contact ITDI, Techno-Transfer Division.
All right. Thank you, ma'am. And here's another question po from Zakia Razo. Can we use many wet materials to get the right moisture or many dry materials?
Well, basically in composting, we have a mixture of wet and dry. If there's a lot of wet waste, you need to balance it with the carbon source or the dry matter. So you can check the proper moisture content using squeeze test. So hindi laging marami dapat. May balance yon. Wet and dry, and then check using squeeze test.
Okay po. So let's see if we still have other questions. So here's a question po that I read from Lourdes Alvarez of PUP. How do you disseminate the information to LGUs that ITDI have these machines that can help process waste into usable form?
In ITDI, we normally have seminars, and LGUs invited us for technology seminar about solid waste. So regularly we have those trainings and seminars on solid waste. And just check our website, ITDI website.
Okay po. And ito siguro tinatanong po ito ng marami na gusto mag-compost. Pwede po ba natin gamitin ang papers or newspapers para sa ating dry materials?
Paper pwede. Yung newspaper kasi, di ba, medyo siya may ink. So, may concern sa use of ink. So, medyo kami sa may mga ink base. Although kung organic naman yung ink na ginamit, pwede. Kung malalaman yung organic siya. So, parang limited ang gamit ng waste. Plain white, okay lang. Shredded. Shredded dapat.
Alright, so thank you for that, ma'am, na enlightened din po ako. So here's, we have a question po from, on our Facebook Live, from DNR Region 4, Raiza Togado. So are there any available composting centers around Laguna that we can get compost fertilizers for free?
In Laguna. In Laguna. I don't have any idea about in Laguna. But if you want to, are you talking about the fabricators?
The question only stated, ma'am, na available composting centers. So siguro po mga MRF, mga opo.
Kasi meron ng Billiard Foundation, di ba? Tapos DA, meron silang mga sariling technology on composting. So you can check those or compare with our technology.
So for this question po siguro, Ms. Raiza can search for other centers po around Laguna. Let me check po if we still have more questions. From Jomel Zaragoza of University of San Carlos, can we use rice hulls as carbon source or dry material?
Rice hull, we recommend carbonized rice hull. Kasi pag rice hull alone, mataas ang silica content niya eh. So hindi siya talaga madidegrade. Super tagal. So carbonized rice hull ang nire-recommend namin.
Okay, ma'am. Thank you for answering that question. So meron pa pong isa from Shaira. How many tons is the capacity of the equipment? Pero wala siyang na-specify na equipment. So maybe this is the bioreactor kasi tons.
Sa bioreactor, we have two capacities, 500 kilograms per day, and the other one is 1 ton, 1 ton per day. So kung LGUs or any adapter, dapat alamin nyo muna yung waste generation nyo per day para makapamili kayo kung anong tamang capacity ang i-adapt nyo. Baka kasi mag-adapt kayo ng 1 ton per day na capacity, pero ang nag-generate nyo naman palang biodegradable waste ay less than 500 or something like that. So, dapat meron muna tayong data ng waste characterization per day. Or yung WACS, yung waste analysis and characterization study. Dapat nakapag-ganon tayo para select tayo ng proper or appropriate capacity ng bioreactor ng baba.
Thank you, Ma'am Myra. So, are there any questions po here for Engineer Herrera about his presentation on the biogas digester po?
Hi, hello. There's a question from the FB Live pala. From Brando Angeles, does the entry of water with detergent content will affect the effectiveness of the potable biogas digester? If so, what do you recommend to household owners in modifying their drainage to accommodate such technology?
Yung soap naman, kung konti, kaya ng bakterya. Pero kung marami na, mapapatay niya yung bakterya eh. Kaya dapat i-divert yung soap sa ibang area.
All right. So, let's see. We still have some questions here in our Zoom. Right. So I'm reading a question from Mr. Alan Arat of Taguig Science High School. So can shells from certain crustaceans and mollusks, for example, shrimp or mussels, be used as a dry material for the compost?
Yes, pwede yan as dry matter. Calcium source yan. Pwede.
And another one po, here is, I think this is a concern po regarding fabrication from Pedro Aquino. So our shop was one of the first batch of accredited fabricators of the 500 kilogram bioreactor. And can we renew our accreditation? Matagal na po
Yes.
kasi kaming hindi naka-renew.
Yes. Okay.
Pwede naman just contact ITDI, yung Technological Services Division namin, to process your papers.
Pedro Aquino.
Okay.
Nalak to.
So I hope we addressed all these questions po from our live viewers and also our Zoom participants. So we are running out of time, no? So for our question and answer. So maybe for other questions po, especially sa live Facebook Live na nagko-comment, we can just reply our answers to those questions. So for our Zoom naman, I think there are still some questions, pero maybe we can also address this on our Facebook page. You can just message our page or DOST ITDI updates page. They also have a page for the Environment and Biotechnology Division. So you can also address your questions to directly to them. Okay, so next. All right, so before we are on